Dear class 10 students, welcome to the YouTube channel me.u. In this session, we'll be discussing Chapter 2, Polynomials, the relationship between coefficients and zeros of a polynomial. In the last video, we studied the classification of polynomials based on the degree of the polynomial. When the degree of the polynomial is 1, the polynomial is named as linear polynomial. The general format of a linear polynomial is ax plus b. Now, to find the zero of the polynomial, we discussed the zero of the polynomial also in the last video. The zero of the polynomial is the value of x such that the complete polynomial value is 0. So here, to find the zero of this polynomial, we'll equate this polynomial into 0. So ax plus b equal to 0. Now, subtracting b on both sides, we'll get ax equals negative b and x equals negative b divided by a. That is, when you substitute x equals negative b divided by a, the polynomial value will be 0. So, the zero of this type of polynomial, that means the linear polynomial, will be always of the form x equals minus b divided by a. So, x equals negative b by a is the zero of the linear polynomial. You can see that a is the coefficient of the variable x and b is the constant term. So, it is negative of the constant divided by the coefficient of a. Now, let's check the relationship between the zeros and coefficients of a quadratic polynomial. What is a quadratic polynomial? The quadratic polynomials are the polynomials when the degree of the polynomial is 2. The general format of a quadratic polynomial is ax square plus bx plus c. 3x plus 5x square minus 2. So it is a quadratic polynomial, but it is not in the general format. So the general format, the standard form of a quadratic polynomial, the x square term must come first. So the general format, the standard form is 5x square plus 3x minus 2 is the standard form. Now, we also learned about the number of zeros of the polynomial depending on the degree. When the degree of the polynomial is 2, at most there can be 2 zeros. So for this quadratic polynomial, the maximum number of possible zeros are 2. So we'll denote these zeros using the Greek letters alpha and beta. Alpha and beta. Now, in mathematics, physics and chemistry, there are many Greek letters used to denote different types of constants or different operations. So you already learned pi. Pi is a Greek letter. In class 9 statistics, you might have studied the symbol sigma for the summation. So it is another Greek letter. So this is an operation. This stands for one operation. This pi stands for a constant. Like that, there are many Greek letters used in math, physics and chemistry. The relationship between the zeros and the coefficients of the quadratic polynomial. Here we know that the coefficient of x square, the coefficient of x square is a, and the coefficient of x is b, and the constant term is c. After finding the zeros, if you are adding the zeros alpha plus beta, that is sum of the zeros, it will be equal to minus of b by a. So minus b by a means the coefficient of x divided by the coefficient of x square. And the product of the zeros, that is alpha times beta, will be always equal to c by a, the constant term divided by the coefficient of x square. Let's solve one of the example. So the question is, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. There are two sub questions in this one. You need to find the zeros first and you need to verify the relationship between the zeros and coefficients. So first part, finding the zeros. The quadratic polynomial is x square plus 7x plus 10. So there are different methods to find the zeros. After completing the lesson quadratic equation, you can use quadratic formula also to find the zeros of the quadratic polynomial. So here I'm using the splitting middle term method. So for that one, I'll take the middle term and the last term, the constant term. Okay. So here the middle term will be taken as the sum of the two numbers. So s equals 7 and product equals 10. So you need to find two numbers such that product of that two numbers is 10 and the sum is 7. So first we'll find all the possibilities of two numbers such that the product is 10. We know that 1 times 10 equals 10. The next option is 2 times 5 equals 10. No other options, right? So and we'll check for which pair of numbers the sum is 7. So we know that it is 2 and 5. So the numbers are 2 and 5. Since the coefficient of x square is 1, you can directly factorize this one as x plus 2 multiplied by x plus 5. To get the zeros of the polynomial, we'll equate this into 0 because we know that the 0 of a polynomial is the value of x, so that the complete polynomial value is 0. So x plus 2 times x plus 5 equal to 0. We know that product of two factors will be 0 if and only if any one of the factor is 0. That means x plus 2 equals 0 or x plus 5 equals 0. Now this is a linear equation, so you can solve the linear equation. X equals, so subtracting 2 on both sides, you'll get x equals negative 2 or x equals negative 5. So these are the zeros. X equals negative 2 and x equals negative 5 are the zeros of this given quadratic polynomial. So we know that the zeros are denoted by alpha and beta, so it can be given alpha equals negative 2 and beta equals negative 5. The first part is solved. We found the zeros of the polynomial. The next part, verify the relationship between zeros and the coefficients. We'll find the sum of the zeros from the answer. So alpha plus beta, we'll find alpha plus beta. What is alpha plus beta? Alpha plus beta is negative 2 plus negative 5. Negative 2 plus negative 5, which equals negative 7, right? We have the relation between sum of the zeros equals alpha plus beta, that is alpha plus beta equals negative b by a. Now we'll check with the coefficients whether it is same or not. We need to check the coefficients. What is the value of a? A is the coefficient of x square, that is 1. B means the coefficient of x, that is 7, and c is the constant term, that is 10. Now we need to find the value of minus b by a and need to verify whether alpha plus beta and minus b by a are same or not. So minus b by a is minus of b by a. B is 7 divided by a is 1. Minus 7 by any number divided by 1 is the same number only. So minus 7 by 1 is minus 7 only. So that means alpha plus beta is negative 7, minus b by a is also negative 7. Means alpha plus beta equals to minus b by a, verified. Now we'll check the product of these zeros. So alpha into beta, alpha multiplied by beta equals negative 2 multiplied by negative 5 equals 10, right? Now the relation is alpha times beta is c by a. We'll check what is c by a. C by a, the value of c is 10 divided by the value of a is 1. So it is 10 divided by 1 is 10. So both are same. That means alpha times beta equals c by a is verified. We'll see next example. Find the zeros of the polynomial x square minus 3 and verify the relationship between zeros and the coefficients. Here the polynomial is x square minus 3. Now the first part, to find the zero. So to find the zero of these type of polynomial, quadratic polynomial, is very easy. So first thing, we know that the zero of a polynomial is the value of x so that the value of the complete polynomial is 0. To find the 0 of the polynomial, we'll equate the polynomial into 0. So x square minus 3 equal to 0. Subtracting 3 on both sides, we'll get x square equals 3, right? If x square equals 3, you can find the square root of square root on the both sides. So you'll get x equals square root of 3. So square root of 3 can be plus or negative. The square root of 4, what is square root of 4? It can be plus 2 or negative 2. The square of negative 2 is 4. The square of plus 2 is also 4. The square root of 4 is plus or minus 2. That means one of the value is plus 2 and another value is negative 2. Like that, the square root of 3 is plus root 3 or negative root 3. So the zeros alpha and beta are, alpha can be taken as plus root 3 and beta is negative root 3 are the zeros. Now the second part, verification. So we need to verify alpha plus beta equals minus b by a and alpha into beta equals c by a. So we'll check. First we'll find alpha plus beta. Alpha plus beta is root 3 plus negative root 3. So root 3 plus negative root 3, we know that it is 0. Now we'll find minus b by a. Minus b by a. So before that, we need to write the values of a, b, c. So what are the values of a, b, c? Here a is the coefficient of x square, that is 1, and b is the coefficient of x. There is no x here, that means it is 0. And c means the constant term, that is minus 3. C equals minus 3. The same polynomial can be written in the standard form like x square. Since there is no x term, you can add 0x minus 3. So you'll get the b value is 0. Okay, so we'll find minus b by a. So minus b by a is minus of b is 0 divided by a is 1. So 0 by any number is 0. That means these two values are same. So alpha plus beta equals minus b by a, verified. Now we'll see the product of the zeros. Alpha times beta equals root 3 multiplied by negative root 3. So root 3 times root 3 is 3, and for one of the number there is a negative, so it is negative 3. Now we'll find c by a. C by a equals, the value of c is minus 3, a is 1, so it is minus 3. So both the answers are same. That means alpha times beta equals c by a, verified. They are same, verified. Now let's solve the exercise 2.2. First question, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. The first question is x square minus 2x minus 8. X square minus 2x minus 8. First we'll find out the values of a, b, c. So already it is given in the standard form. So the value of a is the coefficient of x square, that is 1. Value of b is the coefficient of x, that is minus 2. And value of c is the constant term, that is minus 8. Now to find the zeros of the polynomial, we'll equate the polynomial into 0. X square minus 2x minus 8 equals 0. Now split in the middle term. So we need to find two numbers such that the sum is negative 2. So sum is negative 2 and the product is negative 8. Product is negative 8. So first we'll identify the values of product. Product is 8. If product is 8 means the possibilities are 1 times 8 and 2 times 4. So the product is negative means the product can be negative if and only if one of the number is negative, either 2 negative or 4 negative. So when one of the number of 2 is negative, the sum means we are subtracting the numbers, right? The sum of a negative and positive number is actually the difference of the number. So the difference must be 2 and the sign of the difference will be the sign of the bigger number. So the bigger number must have the negative sign. So the numbers are 2 and negative 4. So 2 times negative 4 is minus 8, and 2 plus negative 4 is negative 2. So we got the two numbers 2 and negative 4. Since the coefficient of the x square is 1, that is when the value of a is equal to 1, you can directly factorize. You can write down this one as x plus 2 multiplied by x minus 4 equal to 0. So plus 2 and minus 4 are the numbers we got. This can be used only when the coefficient of the x square is 1. If the coefficient of x square is any other number other than 1, you cannot use the direct method. You need to split the middle term. So here we can directly use because the coefficient of x square is 1. Now, since the product of two factors are 0, one of the factor must be 0. So x plus 2 equal to 0 or x minus 4 equal to 0. So x plus 2 equals 0 means x equals negative 2 or x equals 4. So we got two values. So these are the zeros of the polynomial. So we can write alpha equals negative 2 and beta equals 4 are the zeros. So we got the zeros of the polynomial. Now we'll verify the relationship between the coefficients and zeros. So first we'll find alpha plus beta. Alpha plus beta equals negative 2 plus 4, that means 2. Now we'll find minus b by a. So we need to verify alpha plus beta equals, minus b by a. So minus b by a equals, the value of b is minus 2, so already there is a negative, and value of b is negative 2, so it is negative 2 divided by a is 1. So negative of negative, when two negatives comes together, so it is positive 2. 2 divided by 1 is 2. So both are same. That means alpha plus beta equals minus b by a is verified. Now next one, alpha multiplied by beta. So alpha multiplied by beta. So that is minus 2 multiplied by 4 equals minus 8. Now we need to verify alpha times beta equals c by a. So we'll find what is c by a. So c by a, the value of c is minus 8 divided by a is 1. Minus 8 divided by 1 is minus 8. So they are same. That means alpha times beta equals c by a is verified. Next sub question, 4s square minus 4s plus 1. Here the variable is s. It is already in the standard form. We'll find the values of a, b, c. A is the coefficient of s square, that is 4, and b is the coefficient of s, that is minus 4, and c is the constant term, that is 1. Now to find the 0 of the polynomial, we'll equate the quadratic polynomial into 0. So we'll write 4s square minus 4s plus 1 equals 0. Now we'll use here splitting the middle term. Notice that here the coefficient of s square is not 1, so it is not like the previous questions. So we need to use the splitting middle term method here to factorize. First we'll select the coefficient of s. So that is the sum. Our required sum is minus 4. And to find the product, we'll take the value a and this one, and we will multiply this one. Okay, 4 times 1 is, so the product is 4. So we need to find two numbers such that the product is 4. The product is a positive number. Product is positive, there are two possibilities. Either both the numbers are positive or both the numbers are negative. Now, product is 4 means the possibility you can see that it is 2 times 2 equals 4. And when both the numbers are negative, so negative 2 and negative 2. So the sum is negative 2 plus negative 2 is negative 4, and negative 2 multiplied by negative 2 is 4. So the numbers are negative 2 and negative 2. So like the previous questions, we cannot directly factorize the polynomial because the coefficient of s square is not 1 in this case. Here we need to split the middle term. So we'll split the middle term, means the coefficient of s will split based on the new numbers. Equation can be rewritten as 4s square minus 2s. So from where we are getting minus 2? So here minus 2s, again minus 2s, plus 1 equals 0. So we split the middle term into 2. So minus 4 can be written as minus 2s minus 2s. Now we'll take the first two terms and the last two terms, and we'll find the common factor from the first two terms. So from the 4 and 2, 2 is a common factor, and in both this is s square and s. S is also a common factor, so 2s is a common factor. When 4s square is divided by 2s, the remaining is 2s, minus when 2s is divided by 2s, it is 1 here. Now from minus 2s plus 1, you can take a negative 1 as a common factor. Why we are taking negative 1? In both the bracket we must get the same. So if you are taking positive 1 as a common factor, you will get minus 2s plus 1 inside the bracket. So we need both the brackets same, so we'll take negative 1 as a common factor. So minus 2s divided by minus 1 is 2s, 1 divided by minus 1 is minus 1 equal to 0. Now you can see that both the bracket terms are same. So we'll take it. It is a common, right? It is a common factor from the two terms. So we'll take it common. So you'll get 2s minus 1 is common. So what is remaining here? Here 2s is remaining. Here negative 1 is remaining. 2s minus 1 equals 0. Now the product of two factors is 0 if and only if any one of the factor is 0, means 2s minus 1 equals 0, or 2s minus 1 equals 0. Solving, you will get s equals 1 upon 2 or s equals 1 upon 2. So you can see that both the zeros are, we got two zeros and both the zeros are same, and we'll name it as alpha equals 1 by 2 and beta equals 1 by 2 are the zeros. This is the first part. Now we'll verify the relationship between the zeros and the coefficients. So first we need to verify alpha plus beta equals minus b by a. Alpha plus beta equals 1 by 2 plus 1 by 2. We know that 1 by 2 plus 1 by 2, that is half plus half is 1. Now minus b by a, minus b by a. Minus b by a, that is minus of b by a. The b value is minus 4. So there are two negatives are coming, minus 4 divided by 4. So negative of negative is positive. So it is positive 4 by 4, that is 1. So they are same. That means alpha plus beta equals minus b by a, verified. Next, the product of the zeros equals c by a. Product of zeros equals c by a. We'll find the product of zeros first. Alpha times beta equals 1 by 2 multiplied by 1 by 2. So it is 1 by 4. Right? The numerators are multiplied, the denominators are multiplied. Now c by a. We'll find what is c by a. C by a equals, the value of c is 1, a is 1 by 4. They are same. That means alpha times beta equals c by a, verified. Now the third sub question, 6x square minus 3 minus 7x. Here you can see that it is not given in the general format or standard form, because the first term is x square, the second term is not the x term, the third term is the x term. So we need to change into the standard form first. Before that, you should not write the values of ABC. The standard form is 6x square minus 7x, the x term second, and minus 3, the constant term. Now we can find the values of ABC. So a is the coefficient of x square, that is 6, b is the coefficient of x, that is minus 7, and c is the constant term, that is minus 3. Now to find the zeros of the quadratic polynomial, we'll equate the polynomial into 0. So we'll write 6x square minus 7x minus 3 equal to 0. Now we'll use the splitting middle term method. So here we can see the coefficient of x square is not 1. So we need to use the splitting middle term to factorize. So first thing, we'll take the middle term, that is negative 7. So s equals, that is sum equals minus 7. The sum of the numbers must be negative 7. And the product of the numbers, to get the product of numbers, we'll take this and this 2 and we'll multiply. So 6 times minus 3 is minus 18. So product is minus 18. So you need to get two numbers such that the product is negative 18 and the sum is negative 7. The product is negative means one of the number is negative and one of the number is positive. Which are the possibilities? 1 times 18 and 2 times 9 and 3 times 6 are the possible values, right? To get the product 18. Since the product is negative, one of the number must be negative and one number must be positive. So the sum means the difference. So out of these three, which has the difference 7? So this is the option 2 and 9. So we'll cancel out other two. So 2 and 9 and 2 negative 9 are the numbers. 2 times minus 9 is minus 18. 2 plus minus 9 is minus 7. Now we'll split the middle term using these two new numbers. So this equation can be written as 6x square. So minus 7x can be written as plus 2x minus 9x minus 3 equal to 0. Now the next step is we'll select the first two terms and the last two terms. We'll find the common factors from the first two terms. So 2x is a common factor from the first two terms. 6x square divided by 2x is 3x. So if you are multiplying 2x and 3x, we must get 6x square plus 2x divided by 2x is 1. So 3x plus 1. So here you can see both are negative and 3 is a common factor. So minus 3. So it is 3x plus 1 equal to 0. Now in this step, it is very important that these two terms must be same. If you are not getting same terms means your calculation somewhere it is wrong. Now we'll take 3x plus 1 common here. The common 3x plus 1. So the remaining terms are 2x and minus 3. So it is 2x minus 3 equal to 0. Now product of two factors equals 0 means any one of the factor must be equal to 0. That is 3x plus 1 equal to 0 or 2x minus 3 equal to 0. Solving the linear equation, you will get x equals minus 1 by 3 or x equals 3 by 2. So these are the zeros. So we'll put alpha, we'll name it as alpha equals minus 1 by 3 and beta equals 3 by 2. So these are the zeros. Now the second part of the question, verification. We need to verify alpha plus beta equals minus b by a. We are checking whether this statement is correct or not. So first you need to find alpha plus beta. You need to find the value of alpha plus beta. Alpha plus beta, alpha is minus 1 by 3 plus beta is 3 by 2. These are fractions. You need to make the denominator same. So 3 and 2, 6 is the common factor. So minus 1 by 3 can be written as, you can multiply the numerator and denominator by 2. So you'll get minus 2 upon 6 plus, you can multiply numerator denominator by 3. So you'll get 9 by 6. So minus 2 plus 9 divided by 6 is 7 divided by 6 is alpha plus beta. Now we'll check what is minus b by a. Minus b by a. Minus b by a is negative of b. B value is negative 7 divided by a is 6. So negative of negative is plus, so it is 7 by 6. That means alpha plus beta equals minus b by a verified. Next, alpha times beta. Alpha times beta, that is minus 1 by 3 multiplied by 3 by 2. Here we can cancel out this 3 and this 3. So the remaining is negative 1 by 2. Now we'll find c by a. C by A equals, the value of C is minus 3 divided by A is 6. So 3 is a common factor. We can cancel out 3 in the numerator and denominator. So it is minus 1 by 2. Alpha times beta equals C by A, verified. Now the fourth sub question. Here also you can see that it is not in the standard form. One of the term is missing. The constant term is missing. So this is 4u square plus 8u, and we'll make the constant term is 0. Right? There is no constant term. So that we'll get the values of ABC. Here the variable is u. So A is the coefficient of u square, that is 4, and B is the coefficient of u, that is 8, and C is the constant term, that is 0. To find the zeros of the polynomial, we'll equate the polynomial into 0. So we'll get 4u square plus 8u equal to 0. To solve, we don't want that plus 0 here, so equal to 0. Now here it is easy. When the first two terms are given, you can directly take the common factors from here and you can solve. You can factorize. The factorization is easy here. You can take 4u is a common factor from the both the terms. So 4u, the first term will be u then plus 2. 4u multiplied by u is 4u square. 4u multiplied by 2 is 8u equal to 0. Now, the product of two factors equal to 0 means any one of the factor must be 0. That is 4u equal to 0 or u plus 2 equal to 0. 4u equal to 0 means u equal to 0. You need to divide both sides by 4. So, you will get u equal to 0 or u equals negative 2. The zeros are u equal to 0 is one of the 0 and u equals negative 2 is another 0. So you can mark alpha equals 0 and beta equals negative 2. Now the second part of the question, verification. We need to verify alpha plus beta equals minus b by a. For that we will find the value of alpha plus beta. Alpha plus beta equals 0 plus negative 2, that is negative 2. Now minus b by a. Minus b by a. So the value of b is 8. So minus of 8 divided by a is 4. 8 divided by 4 is 2. So it is negative 2. So both are same, right? So alpha plus beta equals minus b by a, verified. Next, the second part, product of the zeros. Alpha multiplied by beta, that is 0 multiplied by negative 2. 0 multiplied by any number is 0. Now C by A equals, the value of C is 0 and the value of A is 4. 0 divided by any number other than 0 is 0. Both are same. That means alpha times beta equals C by A, verified. The fifth sub question, t square minus 15. So here also it is not in the standard form. So we'll write it in the standard form first. The standard form is t square, there is no middle term, so we'll add 0 plus 0t minus 15. Now you can find the values of a, b, c. Here the variable is t. So a is the coefficient of t square, that is 1. B is the coefficient of t, that is 0. C is the constant term, that is minus 15. Now to solve, to find the zeros of the polynomial, we'll equate the polynomial into 0. So t square minus 15 equal to 0. We solve the same kind of question in example. So we'll take the 15 to other side. So we'll get t square equals 15, means t equals plus or minus root of 15. So there are two values, plus root 15 or negative root 15. So alpha and beta are alpha equals plus root 15 and beta equals negative root 15. Clear? Now we'll verify. First we'll find the value of alpha plus beta. Alpha plus beta equals root 15 plus negative root 15. So negative and positive of same magnitude is 0. Now negative of b by a, that is minus of b. B is 0 divided by a is 1. 0 divided by any number is 0. That is alpha plus beta equals minus b by a, verified. Next, the product. Alpha multiplied by beta, that is root of 15 multiplied by negative root of 15. So root of 15 multiplied by root of 15 is 15, and since one of the number is negative, it is negative 15. Now c by a, what is the value of c? C is negative 15 divided by a, the value of a is 1, so it is negative 15. Same, that means alpha times beta equals c by a is verified. Now the last sub question of the first question, 3x square minus x minus 4. 3x square minus x minus 4. It is in the standard form, right? X square term, then x term, then constant term. We need to find the a, b, c. A is the coefficient of x square, that is 3. B is the coefficient of x, that is negative 1. And c is the constant term, that is negative 4. Now to find the 0 of the polynomial, we'll equate the polynomial into 0. That is 3x square minus x minus 4 equal to 0. Since the coefficient of x square is not 1, the number is other than 1, we need to use splitting the middle term method. So first we will take the coefficient of x. The sum is coefficient of x, that is minus 1. And for the product, we'll take this number and this number and we'll multiply. So 3 times negative 4 is, product is minus 12. So you need to find two numbers that product is minus 12. So there are different possibilities, 1 times 12, 3 times 4. Yeah, that is the best possibility, 3 times 4, and 6 times 2 is also there. So we will not consider 1 times 12 and 6 times 2 because the sum is negative 1. The product is negative 12 means one of the number is negative. If one number is negative and one number is positive, the sum means the difference. The difference of the two numbers must be 1. So in this case the difference is not 1. In this case the difference is not 1. Here the difference is 1. And sum is negative 1 means the bigger magnitude must be given negative sign. So the numbers are 3 and minus 4. Now we'll split the middle term using these two numbers. So the new equation will be 3x square plus 3x minus 4x minus 4 equal to 0. So we'll use these two numbers instead of the middle term. So 3x minus 4x is minus x only, so no change. Now we'll take the first two terms and last two terms, and we'll find the common factor from the first two terms. Which is the common factor from the first two terms? 3x is a common factor. So 3x square divided by 3x is x, plus 3x divided by 3x is 1. Now from the last two terms you can take 4 as common factor. So x plus 1 equals 0. So you can see that, you can note that x plus 1, x plus 1, they are same. They must be same. Now we'll take the common factor x plus 1. X plus 1 is a common factor. So here it is 3x and minus 4 is there. So it is 3x minus 4 equal to 0. Since the product of two factors is equal to 0, any one of the factor must be equal to 0. So x plus 1 equal to 0 or 3x minus 4 equal to 0. Solving these two equations, linear equations, you will get x equals negative 1 or x equals 4 upon 3. So these are the two zeros. So we'll mark it as alpha equals negative 1 and beta equals 4 upon 3 are the two zeros, alpha and beta. First part finished. Now the second part, verification. So we need to verify alpha plus beta equals minus b by a. For that we'll find the value of alpha plus beta. Alpha plus beta is negative 1 plus 4 by 3. So the first one is not a fraction. So you can multiply 3 and in the numerator and denominator. So it can be written as minus 3 upon 3 plus 4 by 3, which means 1 by 3. So what is minus b by a? We'll find the value of minus b by a. Minus b by a equals negative of b. B value is negative 1 by a. A value is 3. So negative of negative is plus. So it is 1 by 3. They are same, right? So alpha plus beta equals minus b by a. Verified. Next part. Alpha multiplied by beta, that is negative 1 multiplied by 4 by 3 equals minus 4 by 3. Now c by a. C by a equals, what is c value? C is minus 4 by a value is 3. Minus 4 by 3. They are same. That means alpha plus beta equals c by a. Verified. So that's all for today. Exercise 2.2 first question is solved now. In the next video, the question number 2 will be solved. Hope you understood the concepts. Thank you for watching. Wait for the next video. Thank you.